Our second example is going to be 16x squared plus 24x plus 9. And now we could go, excuse me, through the same process that we did with our first problem and use the AC method, and it would work very similarly. But there is another way that we can do it. We have a perfect squares formula. And by that, it means something multiplied by itself. So notice that in our last example, we ended up with x minus 5 quantity squared. So that x minus 5 is a perfect square. And if something is of the form ax squared plus 2abx plus b squared, then it can be factored to ax plus b quantity squared. So notice that our 16x squared could be rewritten as 4x squared, and our 9 can be rewritten as 3 squared. Well, if I pull out a 2, notice that 2 times 12 would be 24, and 4, which is my A value, and 3, which is my B value, would give me that same 12. So it's in that correct form. So we can use that formula instead of the AC method. So we would factor that to 4x plus 3 quantity squared. Now, if you don't feel like using that formula or formulas are hard for you to remember, that AC method will always work. It will also always work even if they're not perfect squares. So we probably need to at least practice that AC method a couple of times to make sure that we really know how to do it. Now, for our next example, we're looking at x cubed minus 27. Now, just like with our previous examples, we want to check and see, do we have a greatest common factor? And we don't. And then also, hopefully, we can see that this time we have a cubed, which is different than the last few examples that we did because those were squares. Something that I noticed right off the bat as well is that 27 can be rewritten as 3 cubed. You might not recognize that right off the bat because you don't have as much experience with cubes. But just like now you should be able to recognize that 4, 9, 25 are all perfect squares, the more that you deal with cubes, the easier that it gets to recognize those perfect cubes. And the reason why we want to recognize that is because if we have a binomial that is made up of perfect cubes, just like with our perfect squares, we have a formula for our difference of cubes. So if we have something that is a binomial that can be rewritten as a cubed minus b cubed, that can factor to a minus b times a squared plus ab plus b squared. Now, the special thing about cubes is that we also have a sum of cubes formula. So we would have a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. Now, hopefully we can see that formula is very similar to the one that we did in our first formula. They both have that a, and it's either a plus or a minus. Both of them are cubed, and it equals A, B, A squared, A, B, B squared. And then if we notice, the only thing that's different are those signs in between. Now, if we look, the sign that's in between our first A and our B is always going to be the same sign as our original. Our next sign is always going to be the opposite. And our last sign is always positive. So if we look at those first letters, we have S, O, A, P, or in other words, soap. So that's kind of a nifty little way to remember our difference of cubes formula. So looking at our example that we have up here, we have our A value is going to be X, and our B value is going to be 3. So when we factor that, we get A, which is X. We're going to have the same sign, so it's going to be minus. Our B value, which is 3. Then we have A squared, so X squared. The opposite sign, so addition. AB, so X times 3, always positive. And then our B squared. So simplifying that second parentheses to make it look a little bit nicer, we get X squared plus 3X plus 9. Now notice that we do get a trinomial in that second parentheses. The nice thing, or just how it ends up working out, is that if you use your difference of cubes or your sum of cubes correctly, that second trinomial is not going to factor. So I know that x squared plus 3x plus 9 is not factorable, and so that would be my final answer. So again, if I'm looking at this, I see, oh, I have 2 terms. I have a y cubed. I probably want to check and see if 8 happens to be a perfect cube. And it does. 8 is going to be 2 cubed. So we can use that sum of cubes formula this time. So we would have our a value, which is going to be y, the same sign, plus our b value, which is going to be 2, times a squared, so y squared, opposite sign, so subtraction, our a value, which is y, times our b value, which is 2, is going to be 2y, plus our b squared, which is going to be 2 squared, which gives us 4. Alright, and then lastly, this one is going to work very similar. The only difference is we have a 3 out to the front this time. That doesn't change a whole lot. The 3 is just kind of going to be carried down through the entire problem. So notice that 64 could be written as 4 cubed. So we would get x plus 4 times x squared minus 4x plus 16. Now, be careful on that last number, because a lot of people make the mistake of just wanting to write a 4 there instead of the square of 4, which is 16. Now, in our last example, it tells us to use factoring by grouping to factor. So notice that we have 4 terms here. So if you have 4 terms or more, we have to factor by grouping. Now, if it won't factor by grouping, then we can have a prime expression, just like 3 or 7 is prime. We can also have prime expressions, and you will have a few that might be prime on your homework. Now, don't get overly excited with just writing prime down on everything, but you might have 1 or 2 that are prime. So notice here that we do have 4 terms. And the way that factoring by grouping works is it's very similar to that AC method. The only difference is that instead of us having to break apart those two middle terms to be able to make our groups, we already have 4 terms. So we can just go ahead and start by writing our groups in. So notice that our first two terms in that first group have an x squared in common. So I'm going to factor out an x squared. And we'd be left with x minus 2. In our second group, notice that we have a negative 3 in common, and we're also left with x minus 2. Now, if you forgot that you needed to factor out that negative 3 out of your second group, we would have gotten a negative x and a positive 2. But hopefully we then would have seen, oh, those are just opposite. I need to factor out a negative, and then my parentheses will match. So now that we have an x minus 2 in both of our parentheses, we can factor that out, and we want to write what we have left over, which is x squared minus 3. Again, making sure to check, does anything in there factor? I don't have any common factors. Notice that I have an x squared and a binomial, but my 3 is not a perfect square, so I can't use that perfect square formula. So that would be my final answer.